Under the Mobil Serv offer, this video is a piece of the on-the-job training curriculum for an energy efficiency study. The goal is to enable you to convert customer needs and opportunities around these activities into improvements in safety, environmental impacts, and productivity. The video is the first part of the OJT curriculum. After viewing it, you should job shadow a competent person completing an energy efficiency study. Then have the competent person observe and coach you as you complete a study. The OJT Participants Guide provides an effective way to guide the trainer and trainee through the experiences to gain knowledge and capability. This video provides an example of an energy efficiency study on a gear drive, but the basic principles apply to other applications, such as hydraulic, engines, or compressors. We target only very select customers and applications for energy efficiency demonstrations, typically on equipment of over 500 horsepower. This presents a good opportunity for a lubricant to have a positive influence on energy consumption, thus providing substantial benefit to the customer. In addition, we want to select customers that are strategic in nature, seen as leaders and influencers in their industry. Our goal is to use these strategic studies as proofs of performance to influence other customers to adopt our lubricants without doing a full demonstration. The ExxonMobil sales advisor and field engineer should consult their respective sales manager and chief engineer for guidance on whether to pursue an energy efficiency demonstration with a customer. Distributors should consult their ExxonMobil sales advisor and field engineer team for such guidance. It is critical to discuss customer opportunity and need to lower energy consumption or improve energy efficiency. Discussion should include topics of sustainability and how improving energy efficiency improves the customer's profitability and position within their market. The customer should have an explicit need to improve energy efficiency. Matt, a senior field engineer with ExxonMobil, has been working with this existing customer on a number of Mobil planned engineering service projects. Dan, his contact at the plant, tells Matt that he'd like them to focus on ways to save on energy costs. Both Dan and Matt believe that an energy efficiency study could aid in validating a decision on whether to change to Mobil SHC synthetic gear oil in the mine's processing plant. Matt explains that conducting an energy efficiency study will require an extensive commitment from the customer company. But in the end, the effort will very likely improve their bottom line, not only from a cost perspective, but also for safety and environmental responsibility. When you bring those three things together, total cost of ownership, safety, and sustainability, it's an opportunity that is a potentially significant benefit for the customer. Typically, you will need to make multiple presentations on the concept and proposed plan to different levels of customer management to get the appropriate buy-in. To help bring solutions and value to his customer, Matt must be an excellent detective and must collect the data needed to plan and support the energy efficiency study. Matt and Dan have decided to conduct the study on a gearbox that drives an iron ore ball mill that is driven by a 3,000 horsepower motor. Matt works with Dan to gather background information on the gearbox, nameplate data and OEM documentation, number of reductions and tooth counts, vibration data, service and repair history, and load data. Matt also reviews previous used oil analysis for oil condition and signs of wear and contamination. Matt, with his customer's help, must carefully study the application and process to understand the many potential variables that may influence the equipment's energy consumption. This evaluation is key to determining the parameters to measure, the measuring devices needed, and the detailed demonstration protocol. Typically, Matt wants to run 4 tests, going from the control mineral oil, then to the synthetic oil, back again to the mineral oil, and again the synthetic oil. This ABAB protocol is the most thorough method for data verification. But due to limited equipment availability, they may choose to do only 1 mineral oil run and 1 synthetic oil run. Matt would ensure enough data sample and load variations take place to establish statistical confidence. Matt will validate that the equipment chosen by the customer will run consistently enough to produce meaningful data. will not be subject to a prohibitive production schedule, for instance, poor accessibility, difficult shutdown conditions, or having long periods before shutdown. And the equipment will be able to produce significant and measurable energy savings. Matt will not proceed without validating the project costs and manpower responsibilities with his customer. He will develop a detailed demonstration protocol and project plan to help with his validation. Just before his site visit, Matt goes over his safety preparations, like customer site-specific training. Many locations have, at minimum, a visitor orientation video. He also reads through the Job Safety Analysis, or JSA, to review the risks and determine the best mitigation steps, including personal protective equipment, PPE. He also prepares and reviews his toolkit, including sensors and data collector. These measuring devices must have sufficient accuracy to measure the needed parameters. Their output must be synchronized to determine the influence of each parameter on energy consumption. In this way, we can determine how changing the lubricant technology, in this case from mineral to synthetic, influences energy consumption. He prepares his strain gauge kit. For this study, the most practical and accurate way to measure the influence of the lubricant upgrade is to compare input versus output shaft torque, especially since the load demand shifts frequently. Matt's toolkit also includes a laser speed sensor used to help calculate the shaft torque, clipboard or tablet PC, infrared temperature gun and thermocouples, flashlight, sample thief, bottles and labels, and digital camera. On the morning of the site visit, Matt, Dan, and the others on the team first review their goals for the visit. Matt goes over his safety plan, and together they review the personal protective equipment they'll need: hard hat, safety glasses, hearing protection, cut-resistant gloves, visibility vest, and safety shoes.
When we get to the work site, I'll show you our evacuation plan and our muster sites. If you hear an air raid siren, that's our evacuation alarm. It means to leave the building, go to your muster site.
Here we are today at the North and Mine. We are going to be conducting an energy efficiency study on this gearbox.
Matt begins with a quick pre-inspection of the gearbox. Considering where to put his measurement sensors and instrumentation, he uses this time to perform an additional safety assessment, identifying hazards and taking any necessary mitigating steps. Matt will keep his head in the safety mode during the entire demonstration. Beyond concern for his own safety, Matt also actively cares for others, so nobody gets hurt.
What we are trying to do from a simple form is measure the work into the gearbox as well as the work out of the gearbox. We're also measuring speed and temperature in relationship to the strain and the torque that's going on the input and the output shafts.
With these data, Matt will have the ability to measure the true efficiency of this gearbox under various conditions, and the influence that switching lubricants will have on this efficiency.
So we'll go ahead and put our locks on to lock out the ball mill.
Now the team can remove the gearbox cover so Matt can begin cleaning the gearbox shafts, getting them ready so he can attach the strain gauges on the input and output shafts. While Matt works on the shaft, others are pumping out the old oil from the gearbox to replace it with a controlled new mineral oil, the A sample. Matt has to get the shaft nice and shiny. He'll attach a strain gauge there. He runs wires from the strain gauge to a tiny battery-powered transmitter on the other side of the shaft. That sends a signal wirelessly to a receiver nearby on the side of the gearbox. Signals from the strain gauges and from other sensors are relayed to data collectors, then to this portable data acquisition system, the Duotron. Matt and Dan check to see that readings are coming in from all the sensors. Sensors include this thermocouple temperature probe. Matt will compare the temperature of each run. Typically, the lubricant temperature will drop if energy efficiency has improved. Tack tape on the shaft can be read by a laser speed sensor to measure the speed of the turning shaft. The team may also use a strobe light to verify readings. So altogether, Matt and his team install thermocouples, laser speed sensors, strain gauges, and vibration probes. The team takes vibration readings on the gear drive during runs A and B for comparison to validate any changes in equipment condition between runs. Meanwhile, the plant crew is finishing up pumping the test mineral oil into the gearbox. Then it's time for everyone to remove their locks so the ball mill can start up for its test run. Matt checks that the data from all the sensors is coming into the system. At the end of the run, as they pump out the mineral-based gear oil, the team takes a sample for later analysis. Now it's time for a second run of the ball mill, this time using Mobil SHC synthetic oil in the gearbox. Matt will gather new efficiency data to compare against that with the previous oil. Again, the team takes an oil sample after this synthetic run. Matt will use sophisticated statistical analysis to validate the correlation of all the variables, including the influence of the lubricant upgrade on energy efficiency. In some cases, the statistical analysis could be accomplished through rigorous use of data tables and manual calculation. But Matt leverages the advanced data statistics software loaded on his data collector to perform these calculations. After completing the energy efficiency study, Matt meets again with Dan to explain his preliminary findings. He tells Dan that he will develop those findings and combine them with charts and graphs from the data acquisition system, plus measurements and photos to prepare an engineering service report for Dan and his supervisors. He must work with his customer in cooperation, not only to gather the information, but to form the recommendations that will produce the best value. Matt steps Dan through the summary screens on the Duotron, leading to the final screen that shows the energy efficiency benefit, focusing on the cost savings, which are broken out in several ways.
So you've got your cost savings from an energy efficiency standpoint, but it also breaks it out from an oil drain extension. And then right around that, with the energy savings is the sustainability aspect, reduced greenhouse gas emissions and what have you. So usually by the time you get to that last screen, the customer is sold.
Matt and his sales advisor will use this report to promote our value to other key contacts at this customer. If very well received, this engineering service report could become the foundation of a proof of performance from this customer that could be used to show other customers, to convince them that ExxonMobil and its distributors are the right lubricant supplier for them. In addition to helping this customer in this one application, Matt will look to see how he can help the customer apply what they have learned to other similar machines at this facility or across their entire company. By using the standard operating procedure as a guide, as well as the other tools described, Matt can consistently conduct these studies and deliver outstanding value to his customer.